When we speak of sound, it's only natural to speak of the most beautiful parts of the sound, which are musical sounds. Nearly all musical sounds are created by standing waves. They can be standing waves due to strings, like in violin, piano, harp. They can be sounds due to rods, like in triangles, xylophone. They can be due to plates, like cymbals, or membranes due to drums, air columns, like pipes, horns, organs. In all of these, we rely on standing waves. I thought it might be useful in talking about sound and music to get an overview on how musical instruments are made. And I thought a good way of doing that is discussing musical instruments that are made with common household items. So I have a couple of videos here. The top one is at this URL from YouTube at this URL. The second one is at this URL. What I have here are cuts from these videos. In the first one, it's a German gentleman who's going to build a musical instrument out of a drinking straw. He does beautiful music with it. There are many more videos you can find on YouTube that might explain in more detail how you can build a musical instrument with a drinking straw, but this one tops them in terms of the quality of the music he produces. So we'll use that to discuss a little bit that particular instrument. And then the second YouTube video is from another gentleman from Australia who, as a career, goes to elementary school, kindergartens, and works with kids, getting them to build musical instruments and play with them. So he has a bigger variety of musical instruments, and that's why I'm using his YouTube. Now let's start with the first one. Okay, in here, what he's doing is trying to make a reed. He's making cuts here to the side, trying to flatten it and making a couple of cuts to the side. Okay, again working on flattening it. Okay, cuts just a little bit more there. Okay, you notice here when he played, he produced only one tone. Now that tone is going to correspond to a pressure node at the open end here and a pressure antinode at the closed end at his mouth. So we have half a segment or a quarter wavelength that's going to correspond to the length of the straw. Of course, he could have changed the note that he was playing by changing the speed with which he blows the air. By changing the speed with which he blows the air, if you remember the equation, lambda is equal to V over F. So by changing that speed, you can change the frequency and the resultant wavelength. So you get a different fundamental frequency for that same length. Now, instead of changing the speed of the air he blows, this gentleman is going to try to change the length by adding holes to the straw. Okay, let's see. There he's adding the holes. A little cleanup. So you notice he's going to block the holes with his fingers. You will also notice that the note that's produced is going to be at a higher frequency whenever the effective length of the straw is the shortest. For example, when he blocks all of the holes, he's going to produce the same sound as the one he produced before he added the holes. In this video, so this gentleman from Australia is going to start with this instrument that's made up of PVC pipes that are quite long actually. So they start at an open end here, they extend all the way up and then down. They are going to look identical on the other side. So they are open in both ends. So, and he's going to tap them at the top here, producing standing waves in the tube, and the sound is going to depend on the length of that particular open tube. In this case, the fundamental frequency is going to happen whenever we have a pressure node at each of the open ends. So a pressure node here and a pressure node in the other side. Of course, the shorter the length of the tube, the higher the frequency for the standing wave. And you'll notice that in the next demo that he shows, which is a variation of this, but using smaller tubes. Okay, let's run it. So low frequency at the long tubes, high frequency at the short tubes. Okay, now he's going to use a string instrument. Pay attention to where fingers are. By holding the string here, he's imposing a node at this particular point. And then we'll have a node at this end. So that determines the length of the vibrating part of the string. Actually, I'm not sure how good the quality of the video is going to be, but if you pay good attention here, you'll see the standing wave as he plucks along. Okay, and this one, it's a tube that's closed in one end and open at the other end. Remember, it's going to be a pressure anti-node here and a pressure node here at the open end.
That's pretty cool. Garden hose trumpets.
So all what you need is a reed, and then you get your trumpet. All what you have to do to get different notes is change the length of the trumpet. So the longer it is, the lower the fundamental frequency.